So thanks for the kind introduction. I think one of the themes of HMI this year is industrial intelligence. And I would like to talk a little bit about it, basically coming from the perspective that we as a more or less IT-oriented company do have a couple of experiences at least around artificial intelligence. So that's basically where I would like to start. Nevertheless, I would like to mention that we have close partnerships with the likes of Siemens or ABB or General Electric in order to make sure we are not losing the contact to the OT world, basically. Let me start with a statement, and I know the data is the new oil statement is somehow, let's say, put into Joe Case's mouth. I heard it that Jeff Immelt should have said that, and so on and so on. But basically, from our perspective, this is really the truth. If we think about the situation, we see 99% of the data is currently not used. So we have a lot of historians, all your companies might have data, might have information in a lot of systems out there in a PLC, wherever, and you're basically not using, let's say, this data in a way to make it usable for you as a company and to gain process ideas and stuff like that. If we look into the daily world, and all of you probably have thought about booking an airline ticket somehow, somewhere, and you experience probably, and there are a couple of press articles out there, that it makes a difference if you try to book that ticket with a mobile phone out of a company in California, or if you book that with a traditional laptop, which is probably from a discount store around the corner. And the reason for that is because all the airlines are basically using AI, artificial intelligence, in a way to predict what you are, who you are as a customer. And that's basically a very tangible example what we feel in our day-by-day life in a way to understand how artificial intelligence can work in that case to the bad if you're an iPhone user, or to the good if you have one of these old Windows 98 laptops somewhere in your cellar and you're able to book your flights with that. And I think there are also a couple of studies out which are basically underlying that. So let me give you a couple of data points. So this is a study we did last year in September on an event called the Industry of Things World in Berlin. And this is about 858 customers which basically responded to that study. And this is not an IT-oriented audience. This is an audience which basically represents all of you. So it's executive level on the operational technology side, on the line of business perspective, and so on and so on. For us as a more or less classical IT company, the number in the middle is pretty important. That is what these customers are spending basically with us. 1.95% of revenue is the, let's say, the average of an IT spending in an enterprise across the globe right now. This is a pretty significant number if you think about the very large enterprises. But on the other hand side, if you're looking to the top number, yeah, a fourth of that is basically something which this line of business people are expected to be spent within the artificial intelligence space. This is a tremendous amount. It's a big opportunity for all of us, I guess, on one hand side, but on the other hand side, it will be also kind of challenging in terms of regulation and things like that. What is also important for us is we see in the media right now a lot that artificial intelligence will be a job killer, similar to the robots. And I think we know now that the robots, if we look in the car industry, for instance, we have growing amounts of people working there, are employed there. So the usage of robots is not at all really killing jobs. It's just enabling different processes, making production more efficient, and probably help these companies to grow. And if we take that survey, again, 858 people, it really says 63% telling us that artificial intelligence will not be a job killer. We'll definitely see a change in the roles. We probably don't have the guy mounting wheels to a car. This is probably already automated today. So similar stuff will happen on the AI side. So we believe it really gives us a challenge. On one hand side, but our society really needs to help us, or we need to work as a society together to make it happen in a way that AI is not killing jobs, but it's really giving us a couple of opportunities. So on this chart, we basically asked the guys, what do you think where AI plays a major role? And you see, we see a lot of stuff in research and development. We heard earlier from Professor Zülke stuff around predictive maintenance. We call it prescriptive maintenance because predictive, from our perspective, is something we can predict. But if we're looking into an assembly line of a large manufacturing customer, for instance, for us it's not important to predict a single device somewhere in that manufacturing line. Some of these companies do have 160 different vendors with more than 500 devices in these manufacturing lines. For us, it's really about prescribing what has to happen when. Yeah, in order to make sure we are optimizing and we are streamlining the whole manufacturing process and not just a single machine, and provide basically a better maintenance for things like that. If you're looking into operation and services, I recently had a chat with a large German car manufacturer, and he talked about the first, the second, and the third life of a car. Usually they can't control the first life of a car, which is basically when I sell it to you, you do your regular maintenance, you sell it to someone else, he's probably also doing the regular maintenance. But as far as the car moves from a European perspective to the east, which is the traditional way of cars these days, yeah, then you lose completely track. Yeah, if the car goes to the south, which is Africa, basically, you lost completely. If you think about sustainability, if you think about economics and things like that, that is really a pity, because you want to understand where the cars are, you want to service the cars, you probably have updates. We all know the combustion situation right now of a couple of European car manufacturers. And if you would be able to track these cars, to understand where they are, to offer additional services, this is really a big thing. And we believe also on the AI side, we can do something good. But we have a lot of chances, that's great, but we also have the opposite side. This is basically the obstacles which have been seen by the audience. And if you take the top three, we heard it from Professor Zülke, availability, quantity of data. So where is my data? Where do I have the data? You all have in your manufacturing line a lot of PLCs, you have drives, you have conveyor belts, you have robots, whatever, and they all store the data somehow. You probably can access them, or you probably can't. So this is probably one of the challenges here. We also have a lack of data governance. You don't know where the data is, you don't know what it is meant for, and things like that. So these are the three, and we all know that we have a lack of AI experience basically on the market. This is just a problem, not here, just here, also in Silicon Valley. If we look about what we have to pay for data scientists in the San Francisco area, and what our friends from Google, Facebook, and the others are currently paying for these people right off the university, this is incredible number. So from that perspective, we think there are a couple of challenges to solve. If you have someone in your family starting the university career, I highly recommend going in the, let's say, data scientist space. That seems to be a very safe job over a very long period of time. So how do we approach that stuff from a more IT-oriented perspective? Again, with our partners on the OT side, we really believe that the world will be edge-centric on one side. So Gartner says 2025, 75% of the data will be generated and processed out of the data center, which means also outside of the cloud, because the cloud is basically just a replication of a data center. It's just somewhere else. So from a latency perspective, from a security perspective, from a compliance perspective, probably a lot of data will be processed at the edge. On the other hand side, we have the cloud. It is obvious that the cloud will not go away. It will be staying there, and there's good reasons for this, and we all might know what the reasons are. We have big compute availability, capabilities available basically on your fingertips, but this is not really what you really need all the time. We have an example, and that comes to the data-driven point. We have an example of an oil and gas company which do have oil wells somewhere in Africa. They have their central data center in the US, in Texas, in Houston, and it takes them 5-minute round-trip time. Get the data into the data center, process it there, send it back. And if you think about you're drilling a hole 3 miles in depth, you want to understand if your oil well will probably, or if the stuff will break. You have torque, you have pressure, you have temperature, you have all this information. And usually the outcome, if you process this in a small device based on a standard model, is not that different. It's somewhat 99% close to the reality than if you process in the cloud. And these are examples where we are basically running edge compute in these environments. Data-driven, I mentioned earlier the airline industry, I mentioned the car manufacturer who wants to understand his assembly line, I mentioned the oil and gas industry. We have a lot of examples out of the process industry, out of the high-tech industry. Seagate, big customer of ours, is using edge computing in order to, let's say, raise the quality of the devices and try to sort out as soon as possible some of the broken stuff. Allow me, please, a little look into the past. So we all remember probably mainframe computers, these nice little green things. There are a couple of younger people in here which probably don't remember that. Then we had later the client-server infrastructure, which gave us also a couple of new experiences. Currently, we are more or less in the cloud mobile world. Everyone has a smartphone, and I had a couple of interviews the last couple of days, and they're coming with their iPhone. Yeah? There's no one coming with a real camera, no one has real microphones. They're really doing everything with smartphones, and that has a pretty interesting quality. But from our perspective, this will slightly change just for one reason. And that is basically the amount of data which is prognosed will be the 2020 number. To give you an idea, a zettabyte is 10 by 21. So it's a pretty long number. And that's basically the data growth we're currently seeing. And that will be very difficult to cope with in the cloud, in a regular data center. And frankly, most of that data is probably nothing you really need. If your assembly line runs in a way that everything is fine, you probably don't need to collect all the data. You need to make sure that you're just collecting the anomalies, or you detect between a certain threshold the data which is probably not running in a way it should. To put that a little bit into perspective, Walmart's transactional database in 2007, Walmart is by far the biggest retailer on the planet. Yeah, a couple of thousand retail stores in the US and Canada, I think 600-something thousand employees, so a very, very big number, a big customer, 40 petabytes. Human data in the middle, so content, I wouldn't say it is created. It's, from my personal perspective, more content than stuff which is created, which is uploaded day by day to Facebook. It's about 4 petabytes a day. You can do the calculation. It's a tremendous amount which is uploaded to Facebook. On the right-hand side, the amount of data which will be generated by autonomous-driven cars, and it's just 10 million. To give you a perspective, Renault-Nissan, currently the largest car manufacturer on the planet, is right now producing 10.7 million cars, and there's Toyota out there, there's Volkswagen out there, there are a lot of other companies out there. So you can imagine that that number will grow exponentially. And to give you one more view on this, if we think about the left, this is very clear data. I bought something from Coca-Cola, I shipped it to my store in San Francisco, and I sold it to a customer after 3 days, shelf life. That is pretty transactional data. You know everything, you understand what the data points are. If you go to the right, it's basically the transition from an analog world, what the car sees, feels, and expects, that is an analog world, transferred into digital, and you need to process that data in a hopefully very useful way, which gets you a couple of, let's say, insights which you would like to have. Let me recap this. Today, about 10% of all data which is generated is processed outside of the data center or the cloud. So this is stuff which is currently happening. We've seen earlier from Professor Züke, OPC-UA-based devices, things like that. That is processed right now outside of the data center. And I mentioned it already before, 75% of that in 2025, and again, these are Gartner numbers, so nothing we came out of our mind, are basically will happening outside the data center. To put a little disclaimer on that, in all fairness, Last year, the number was 75% in 2022. So also Gartner considered themselves a little bit and is basically moving that number out a little bit. Especially in manufacturing, by the way, we see a huge demand, and we've seen the slides from Professor Sülke earlier. A lot of data is currently being processed in the manufacturing floor, and not a lot of that will be basically used in a way that you can understand how you can improve production, how you can improve R&D, or even how you can improve your after sales. We have examples from customers where it took almost 2 years from them understanding they have a problem in the field until they can change production in a way that this problem will not occur. So from our perspective, what we will see in the upcoming years is that we will have a huge, and coming back to the theme of HMI, we will see a huge, let's say, impact in the industrial intelligence space. A lot of stuff will happening decentrally. I will not disagree to what Professor Zülke said earlier, that a lot of stuff will also happen in the cloud, but we strongly believe that big models, big algorithms will still be done in the cloud, but we expect a lot of stuff will happen on-prem. We had the car example. I think every one of us understands that completely. On the other hand side, I would like to make sure that if I'm entering a robot cage, the robot stops when I'm entering that, and I'm not hoping for any given cloud provider out there that he processes the data in time, and the telco provider sends it in time back to the robot cage and make sure the robot stops. That is stuff which will happen. If you think about process industry, if you think about high-tech industry, they have all these use cases, and we think we go in a similar way. Again, my chart from earlier, I expected always on the left side, sorry for that. If we take the data volume which will be generated, one important thing, if you take Moore's law, and it has to be proven right over the last couple of decades, we basically have a mismatch between the processing power and the average data volume. I had earlier today a session with a couple of social media influencers, and we had a discussion around circular economy and that topic. And if we think now how we can improve our usage of energy, our usage of the resources overall, we need to close that gap. And from our perspective, honestly, that will go if we are really moving in a direction to use data, which is currently, I mentioned the 94% earlier, I guess, to generate or to use the data, to analyze the data, basically at the edge where it is being generated, and making sure we are processing it the right way. So to give you a couple of examples before time is running out, I would like to highlight 2 of them. Centerpoint Energy, it's a Houston-based, let's say, energy company, and they had a couple of challenges a couple of years back when a couple of hurricanes went through Houston. They had an average downtime of 4 days 5 years ago. Yeah? Average downtime for every of their about 10 million customers. So that means some of them had a couple of hours and some of them had a couple of weeks. Reason for that is if you want to drive an energy grid, you need to have supply and demand on the same level. And it was quite difficult for them to understand which customer is out, which customer is still running, which substation do I have connection, and which one not. Bottom line, we went down with a couple of smart meters in the US, about 10 million, so every single customer got one of them. We basically went in a direction to connect all these customers back to the central organization, which allows them to understand which lines are likely being broken, which substations are probably underwater, and that gave them an average downtime. A couple of years later, they had another hurricane, I think it was Ike, and they gave them 4 hours. So they reduced the downtime from 4 days into 4 hours. On the right-hand side, and by the way, we are currently working with them together with our partner ABB and SAP in a way to put a self-healing grid. That's their idea. So basically having a situation, thinking about AI, basically using edge compute to understand where the lines are broken, where the substations are underwater, and make sure to reroute demand in a way that they basically can cope with that, and having more or less a self-healing grid and understanding exactly where they need to send crews out in order to fix some stuff. On the right-hand side, that's pretty important for us. I'm standing here, I'm in a CT role. We can think about everything, which is right or probably right or whatever. But really important is to work with customers. And on the right-hand side, we have a customer called Texmark. It's a customer where we basically have an active test bed in a chemical plant, which has all the, let's say, production processes like also the biggest refineries have on the planet. And we're basically using them to test out, in that case, we work very closely together with Intel and Deloitte to test out some cases how edge compute can work before we really starting putting that into our customer environments. So again, we believe edge to cloud will be the strategy. We believe that everything needs to be connected in a secure way. We haven't touched on this, but there's also a couple of challenges if you think about a robot cage and having not the right connectivity, being not secure, that probably gives you a personal challenge by being hurt or being killed. We believe intelligence will be, let's say, embedded everywhere, and you know that if you shopped for household appliances the last couple of years, you see more and more connectivity options, stuff like that. And we believe that we will understand way more than the 94%, which we've seen earlier. We believe that a lot of this data, which is out there, needs to be understood in a different way, and that gives us a slightly different view on the world. To give you one final example, this is an airplane which you probably can see, and the company who bought another airplane of these, basically, and there's a process called airworthy readiness, which is a big challenge right now. We see the 737 MAX discussion right now on the outside. But there's a very stringent process which is controlled. But even in that process, you need to keep your brain in the process. You probably see that there's a little F missing on the other plane. So they simply used everything in their process. They got the information, they got the stickers, they got everything for the plane. They just missed an F. So my call to action is basically, AI is great, we can do a lot of stuff, but we still keep the human factor somehow in the equation in order to make it successful. That's it from my side. Thank you very much. Have a great day today and enjoy the conference.
Thank you very much, Mr. Roese. So just stay a moment with me on stage.
Okay.
Yes, really, I surprise you.
Thank you.
We want to give the opportunity, if you have any questions to Mr. Roese, because we are really good in time, please raise up your hand. So the microphone is coming to you, sir. Here, there, gentleman over there. First row.
So I wanted to come back to the question of the amount of data that you showed being generated and your comment about Moore's Law gapping out when you reach the 47 zettabyte level. A lot of that data, if we go back to the automotive example, is video data.
Yep.
So what's the bridge between that high volume of video data and your gap out in Moore's Law? And there's got to be something accounting for how that video is processed that's not traditional Moore's Law.
So I'm not sure if I got your question the right way. So what we're currently doing, using our own manufacturing process, we're still a very big manufacturer of our own gear, 6 servers per second or something like that. And what we're basically using in terms of video analytics is basically processing it right where the data is being generated and then completely throwing away the picture beside one picture, which is the one which goes into the store for a digital twin type of thing. So did I get the point?
I think I was trying to get what the role of video acceleration hardware itself is going to be. It's too loud. In the video processing units, the graphic technologies that have more capabilities faster than Moore's Law.
That's completely.
Way too high.
That's completely true what you're saying. But quite frankly, we do a lot of stuff in the video analytics space, and GPUs like from the known vendors right now, we see a lot of stuff which could happen on the FPGA basis. And we believe that also a GPU is still kind of general processing, and we believe that a lot of stuff will go, and we have a couple of, let's say, research projects going on with some of these classical manufacturers of this GPU stuff, which goes way more into ASIC and FPGA compute, which will give us additional benefits exactly and probably helps us out there. If you think about Moore's law, the general idea is more the x86 world, general purpose compute, and not really special purpose compute or FPGA, but I doubt that GPU will be the only answer. What we see right now, especially in the video analytics space, is that also GPUs are a bit general processing.
Thank you. Does anybody else has a question? Just raise up your hand. Gentleman over here and over there. And yes. And after you, the gentleman there.
Okay. I wanted to put my hand into it, but I was afraid. Anyway, David Brosel from the Manufacturing Leadership Council. In your survey on AI, you identified as the #1 challenge a lack of data quality. What's the issue there? Could you elaborate a bit on that? Is it disparate formats? Is it just bad data from the point of view of being inaccurate about something, or what? Could you elaborate a bit on that?
Well, what we've seen, and we spoke to a couple of the respondents, what we are seeing is basically that some of the data is just brownfield information. If you think about a traditional manufacturing plant somewhere, it is nothing we're building right now from a greenfield perspective. So what we're seeing here is that a lot of data within, I shouldn't say silos, but just the only expression I know, is that we have a lot of different silos within the manufacturing process. So the conveyor belt people are not talking to the welding people, and the welding people are not talking to the painting people. And from that perspective, you have a lot of different data sources. That's similar to the example I had with the car, where you try to, let's say, move analog data into a digital world, which gives you a hard time to get that understood. And what we're seeing right now in projects is that we really have a hard time to gather the data, to understand what the data means. Yeah? We have examples that US-based machinery is using US-based inch things, and we use centimeters. And sometimes, and we've seen that with the ABUS 380 at the beginning, they had a couple of issues with the data, with the cable length, which just 10 centimeters missing, but in an airliner, probably a bit challenging. And that is basically what we're seeing right now. So it's all what you said, and it's, from my perspective, really the question, what data has become, let's say, relevant, what is stored, what is not stored. We see also a lot of information which is just being sent to def 0, which is basically being burned into energy within the processor, and that is stuff which is really hard to change, especially due to the fact that these production lines are running probably 5, 10, 15, 20 years. And from that perspective, we have a real challenge to get that data in a way as we would like to have it if we would start now, getting all the data. We've seen OPC UA earlier. If you have everything OPC UA standardized, you get all the data in the right format, and it's no issue. But if you have stuff out there which is probably 10 years old, and in the OT side, on the IT side, we would like to see the customers changing every 3 years the whole gear. Yeah, and that is happening quite often, sometimes 5. But if you go to the OT side, 10, 15 years.
Okay. And we've had a third question over there, the gentleman. You can just throw the mic to him. It's more fun. Yes. Great job.
Hello, I'm Alan Mulu from Synergies. I saw your picture that shows there's a gap between the data in the future and the computing power. There's a gap, and I have 2 sub-questions regarding to that one. The majority of the data growing is from structured or unstructured? And the second is how edge computing can solve this problem. Thanks.
Thank you very much.
So right now, in the stages we have right now, I think the data growth comes still from an unstructured world, because a lot of companies thinking that digitalization is right now the way to go, so they're trying to get as much data out of the systems as they could. So from that perspective, right now it's unstructured, but I hope for all of us that we will come to a structured approach like the OPC UA one pretty soon. To the second part of your question, well, generated data doesn't automatically mean it's useful data. So we have a situation, and that's what I tried to explain earlier, with the threshold thinking, that if I have a manufacturing process and I'm measuring a temperature for a given product in the chemical field, and if I'm between a threshold of 38 and 40 Fahrenheit, for instance, I do not need to track that all the time. I probably track it every 5 milliseconds, but I only send every second one data point which says, well, I was fine within the last minute, for instance, and I send that data back. That can be done on the edge. Yeah? If I want to be basically precise, then I say, well, if it goes below 38 or more than 40, then I basically go out and say, well, I send that data immediately back, and every single data point which comes later, which is out of the threshold. And that means we are reducing the amount of data which is still being generated, but we basically throw it away right where the data is being generated. Does that answer your question? Yes. Okay, cool.
Yes.
Thank you.
Okay, so thank you very much, Mr. Roese.
Thank you. Bye.